Hello, everyone. Good afternoon. My name is Andy. This is going to be the third homework video for Meta 25. In this video, I'll be talking about some problem that is in Meta 25's section 5.2, the fundamental of definite integrals. For every section of homework in Meta 25, I will make a walkthrough video of the homework problem to walk through what are the steps and what are the tricks in addition to my homework hint guide. My intent to do so just to save more time to doing homework because I know that the college student, you have lots of commitment outside of school and you have other classes and you have your own life. So I hate to this homework take you like 20 hours a day just to like you can suck on because I don't want to have a bad experience of taking Math 25 as for any math classes that you got. So I'm making this video, I hope it's helpful. So the first one is a midpoint. So make sure to find the width of how wide is each interval is. Just find like a delta x of like this approximation. So 12 is delta x, and the midpoint we take the midway through each subinterval. We take x equal to a 6, 18, 30, and 42. Make sure your calculator is in a radian mode. Number 2, we just increasing function. It just makes sure that the lower estimate is produced by left endpoint approximation, and the upper estimate it is produced by the right endpoint approximation. Just be careful about like the behavior of the function. If the function is decreasing behavior, the lower estimate is provided by right endpoint approximation, and the upper estimate is provided by left endpoint approximation. Now, just read the graph here. We have from a equals to 0, b equals to 10, 5 subintervals. We find like a delta x, it is going to be 2 here. So v for right endpoint, we do 2, 4, 6, 8, 10. Left endpoint, we do a 0, 2, 4, 6, and 8. And for midpoint, we take the mid of each two. So we take 1, 3, 5, 7, and 9. This is all we're going to take. For number 4, we do the reverse for that what you did in section 5.1. In 5.1, we convert the function into like Riemann limit form, and now we turn the Riemann limit form into normal functions into Cartesian forms. We have like intervals given here. We have like a delta x, and we have this xi natural log of 2 plus x squared y. How to convert into it? Just remove all the I, just all this subscript I. So the function is x times natural log of 2 plus x squared. That is your function, and the dx it is here. And number 5, it is like a net area. The only warning for this graph it is from x equals to 6 to 18. This semicircle it is under the x-axis. So its area it is positive, but it is under the x-axis, so it is negative. So when you do the definite integrals here, if you just the average goes from like 6 to 18, make sure at the value it is a negative this area. You probably know how to find the area of a circle, right? Just to find the area of the circle have like a radius. The radius it is 6, and then just divide the circle area by 2. Geez, there's a number 6 here. This is the net change. So if the output produced by x minus 10 is negative, then we will swap the function. We make it to 10 minus x, and then we just, in this case, we need to split up the integral. This is going to be net change theorem that you will encounter in section 5.4. The net change area, and this is going to be the total distance traveled from 0 to 20, and it should be net positive because this is just the total area, not the net area, not just like you computed like definite integral from 20 of the definite integral of x minus 10 from 0 to 20. That's two different things. For number 9, just to do the definite integrals properties and make sure you swap the bound. Once you swap the bound, the sign before the integral also changes. If you have a negative sign, before, now just to switch to positive. At the meantime, the upper bound, the lower bound also just change the order. Then if we swap this integral, we will have the -4 in the upper bound and the -1 behind the lower bound. And number 10, we have this absolute minimum value is m, absolute maximum is capitalized M between what two values. We have the property 8, if m is smaller, 8 is smaller or equal to this definite integral, and then if m it is smaller than f of x and smaller or equal to m, then the m times b minus a is equal to or smaller than the definite integral, the smaller than equal to the capitalized M, b minus a. We apply the third one. The same rule apply for number 11. For number 12 here, it seems complicated, but you just need to rewrite the function in terms of x. So to the y equals to blah blah blah. Here do some algebra here. So once you're doing the approximation, you don't do the first quadrant. That's only 1/4, 1/4 of the like ellipse. So after you approximating the first quadrant of the ellipse, make sure to multiply the result by 4 to obtain the approximation of the entire ellipse. Yep, I think that will be all for section 5.2, the definite integrals, and hope you guys have a wonderful weekend. And today's April Fool's Day. If you have it not fool anybody yet, just go just to fool somebody. That would be a fun experience. That is once a year. And I will see you guys in the video for section 5.3. Have a great weekend.